Hello, welcome to this webinar in which we'll be talking about achieving more with less by optimizing your plant. My name is John Campbell. I'm the Global Product Manager for Advanced Process Control at ABB, and I'm joined today by Kiran Darmasseelane, Principal Analyst of Verdantix. So what we'd like to talk about is a little bit about how advanced process control and optimization at ABB are changing things for our customers, as well as understanding what customers in general are seeing in the industry. So let me tell you a little bit about ABB. We're a global leader in electrification and automation with a strong commitment to helping industries achieve their decarbonization and efficiency goals. We have a variety of ways that we can do that. In this session, we'll talk about how ABB Ability Optimax and Advanced Process Control, our RTO and APC solutions, help customers with these improvements. These solutions can help with energy-intensive industries by stabilizing processes, cutting emissions, and achieving faster returns on investment. I'd like to ask Kiran to explain a little bit about his role here.
So I work for a company called Verdantix. We're an independent market research and consulting firm specializing in understanding the technology landscape to help firms make smarter decisions, de-risk investment choices, and accelerate digital strategies. As part of our ongoing research, we've got a dedicated team that focuses purely on researching innovations across the asset-intensive space. We look to help engineering, operations, maintenance type leaders to achieve their strategic objectives. And as part of that, we've looked extensively at how industrial technology, such as advanced process control, can support ongoing decarbonization initiatives. So what I plan to do over the next couple of slides is give you a bit of a market overview of where we see the market today and how APC can start driving decarbonization value. If we look at the market today, I think we all know that decarbonization is a top priority for all industrial firms. Whether you're a pharmaceutical, oil and gas, manufacturing, or even a construction firm, we could see that there's significant goals and aims to reduce CO2 emissions by 2030, 2040, 2050. Really, all firms in the industry today are making quite ambitious net zero related targets.
Well, Kiran, I'd like to ask a question about this. I'm a little curious how the customers, this is fascinating because they have all sorts of different goals and objectives. Are they competing with each other? Are they looking at their peers? How are they obtaining these goals? What do you know about that? Because I realize net zero is the ultimate goal, but I can see here some specific benchmarks along the way.
Yeah. When it comes to setting these goals, are they competing, how they're setting it, what's going on there? There's an essence of competition here for sure. Companies don't want to be seen as kind of lagging behind their rivals. If ExxonMobil comes out and sets a goal, other oil and gas firms, Shell, BP, ENI, etc., are all going to be looking at those goals and thinking, should they be doing the same? Because they don't want to be kind of seen as having weaker commitments. They don't want to damage their reputation. They want to make sure investor confidence is at an all-time high still, keep that relationship with their customers, etc. So there's definitely a bit of a competition there to make sure everyone's kind of on the same level field. It's almost a race, if you want to call it, because while firms are looking to kind of stay competitive with each other, others are also trying to be first movers here as well, right? So you want to try using technology and other aspects of the kind of decarbonization to be the forefront of it and kind of get that competitive edge for sure. In terms of how some of these firms are being first movers, you want to call it, and kind of setting their goals, really regulations play a big factor here. So you've got things like the SBTi, science-based targets, the Paris agreements, etc., which kind of help you envision where you can get with things. You've got kind of regulatory pressures, stakeholder expectations that all kind of expect firms to make big claims around emissions reductions. And you've also got things around kind of technology assessments to see what you already have within your business that can help you achieve those goals. So it is a bit of a mixture of kind of looking at what other people are doing, but also kind of looking entirely to see, okay, based on what is actually available, what could I potentially achieve over the next 5, 10, 15 years or so?
Yeah, I like that. I like the idea of working with fast movers because with our solutions, which are software solutions, they're easy to implement as opposed to making capital expenditure changes to your processes. So I feel like there's two different ways. So if you want the quick hit, you want to do something with software to help you achieve these goals. And so seeing people that are fast movers is always kind of interesting to me. Thank you.
Yeah, I guess we kind of just touched on this point here, but kind of one of the big reasons we're seeing a lot of these claims on emissions reductions and energy targets over the next couple of years is because of regulations and the impact that has on brand reputation. If we're talking about things like climate goals and regulations, I mentioned the Paris agreements, but we've also got things like the EU Fit for 55, the US Inflation Act, which is kind of incentivizing US firms to invest in clean energy and efficiency improvement capabilities. On the other side, like I said, sustainability, carbon reporting activities around TCFD, CSRD, SEC, etc. All these things are kind of making the idea of decarbonization and carbon reductions more like a mandatory thing rather than just kind of the traditional voluntary reporting side that we've seen in the past. And what that really talks to is this idea that decarbonization today is no longer just an optional thing. It's something that firms have to do, or you're going to be hit with huge fines, reputational damage, and you're going to really fall behind compared to the rest of the competition in the market. But it's not just we're seeing this from a market point of view in terms of what governments are saying, regulations are saying. It's also from an investment point of view. So for those not too familiar with Verdantix, at the start of this year, start of 2025, we went out and interviewed 304 industrial executives across operations and maintenance roles to really understand their preference for, or their technology preferences, budgets, and priorities. When we questioned them about decarbonization plans for the year ahead, their digital transformation plans for the year ahead, we saw that decarbonization targets was the most significant factor in driving digital transformation for their plants. While over 50% of firms were actually looking to increase investment in decarbonization to support plant operations over the next 12 months. Really seeing there that decarbonization initiatives are top of mind from an investment point of view for industrial firms today.
Yeah, I noticed that the corporate decarbonization targets and the cost reduction and efficiency improvements are roughly have the same pull from the customers. They're rated these about the same. How related are these two drivers?
Yeah, good question, John. And maybe should have put a red box over the first two rather than just the first one. But I'd say decarbonization and cost reduction are heavily linked for sure, especially from an industrial point of view. And we'll probably get onto this a bit more in a couple of slides in terms of kind of what we mean by decarbonization and how the traditional role of operations and maintenance has changed over the last few years. But if we take general kind of plant optimization and maintenance activities, things like reducing steam consumption, optimizing heating integration, minimizing flaring, that has huge benefits on operating costs, but also huge benefits on reducing CO2 emissions. So technologies like APC, where you're looking at kind of improving the control of your operations, really sit at that intersection of decarbonization and process efficiencies, because you're looking to reduce inefficiencies across the whole board, not just from a production point of view, but a emissions point of view, and looking to kind of stabilize your whole process and have that double benefit of environmental and kind of profitable benefits for the company.
And it's funny that I think that the lack of availability of skilled workers and the last one, the availability of AI, they're related as well, because as AI comes on, you're actually helping the workers. So, top of mind is the decarbonization, but I know that these guys are worried as well about some of the other things. So I have another question. How can these producers maintain momentum in process improvements when, regulatory and economic and geopolitical things like you've been talking about are changing? So what's the secret there?
It's a good question, because there's a lot of uncertainty in the market right now. I'd say what you would need to do is focus your initiatives to stand more on, focus initiatives to be more than just for compliance reasons. Things like advanced control optimization projects deliver kind of significant cost savings, yield gains, improve reliability for firms. So it's kind of making sure that what you're doing is not just about brand reputation or compliance needs, about you're improving your efficiencies, you're doing more with less, you're kind of achieving the overall strategic goals of the company. And that's a huge part of where you've got to go with kind of these sort of investment decisions, for sure. I think the other side of it is also thinking about it from a people point of view. What we're seeing is that even though there's so much political regulations coming in that are influencing the C-suite and your leaders, there's a lot happening on the front line for operations and maintenance managers that are changing what they do day to day, that's influencing that overall investment side. So if you take something like your traditional process optimization goals, here historically you're focused on optimizing production, improving efficiencies, didn't really have a focus towards anything other than that. But now, more recently, we've seen things like you've got to consider reducing energy consumptions. You've got to consider reducing waste and emissions. You've got to implement some sort of sustainable practice. Maybe that's integrating renewable energy into your process. But it's just widened the scope of what you look for when you talk about process optimization. And it's a similar thing for resource management, where it's no longer just focusing on managing the personnel, labor, equipment, materials from a cost point of view, but it's also looking at how that impacts the environmental side of things. Is there a more environmentally friendly way to procure some of your spare parts and assets? How can you drive a more net zero based culture for the business? And it's a similar idea on maintenance side. You're not just optimizing your maintenance workflows, but now it's also kind of considering what's the environmental impact of your maintenance decisions. How are you going to mitigate risk and improve safety across the whole operations you're conducting? And what that ultimately brings is this idea of having to kind of continuously improve, constantly evaluate your processes and identify opportunities that help you improve performance, as well as kind of bottom line revenues and emission reductions and waste reductions, etc. So what we're seeing at Verdantix is there's probably 3 key ways to achieve this, or 3 kind of key technologies. But what we're effectively saying is that what we see in the market today is that you have 3 types of decarbonizing technologies. You've got your clean energy transition tech, which is really focused on shifting from, I'd say, a high carbon to a low carbon source. You've got your advanced decarbonization solutions, which are more focused on significant reductions to your carbon emissions. And then you've got your efficiency improvement technology. This is more your low-hanging fruit, often more software-based investments, really focused on optimizing the day-to-day energy use and kind of focus on reducing waste as well. When it comes to... Go on, John.
I was going to just say, I think that this is interesting because what you're doing is making some of these processes more complex. And now you have more than just what I would consider a control problem. You have an optimization problem. How do I get these different processes to work together? Where should I be generating energy? Where should I be pulling energy from? And that's quite a complicated optimization problem. And again, it's a easy software solution to a complicated physical solution. So
yeah, so it's a great point. And it's not just the complexity from a process point of view. I guess the other side is the complexity of where do I start? There's probably 15, maybe 20 different technologies I've listed here on the slide. That's not even, I wouldn't say that's an exclusive list. There's probably hundreds of others that could support decarbonization goals. So how do you know what you should be doing? How do you know where's the best starting point for you? And when you're kind of considering that, I think the things you need to consider is what's happening in the market today and what's going to give you the best benefits on a short-term and a long-term investment point of view. And if we take things like clean energy, transition techs, and advanced decarbonization techs, these are technologies that have huge, significant capital investment, right? You're talking about things like green hydrogen, CCS, combined heat and power applications, often need significant investments, take quite a lot of time to come to fruition. And it's kind of making these kind of more significant investments more of a kind of, I guess, a nice to have investment decision rather than a must have investment decision. But the other side of it all is that, as we said at the start, there's still these ambitious growth and net zero targets. We've still got regulations coming in. There's definitely still needs to be action towards getting towards net zero, but maybe not at the rate of let's invest multi-millions into a direct air capture plant. Instead, that's where I think efficiency improvement technology really play a huge role. It's kind of technology that, I said, acts like a low-hanging fruit. It's investments that look at optimizing what you already are doing today to gain improved efficiencies, improved reductions, but also looking at reducing kind of emissions goals, in optimizing energy, etc. And that's really where kind of APC falls into this world as well. I'm going to hand over to John after this slide to talk more about kind of APC and where ABB sits into this. But looking more generally at the technology itself, we really consider APC as a fundamental technology supports optimizing the whole plant, and that directly supports the whole decarbonization journey. So if you look at the APC hierarchy I've got on the right-hand side of the bottom of the pyramid, you've got that kind of manual control process. Really, operators are looking at adjusting process variables. It's very labor intensive. It's very reactive. And from an energy point of view, typically you're wasting a lot of energy just because it's manual operations. If you move up to that kind of basic control level, you're introducing feedback loops, PID controllers. It's kind of stabilizing the process, but you're not really optimizing anything. It's very much kind of an efficient way to do manual control, but still having a lot of wasted resources and energy. So go to that advanced regulatory control side, we're definitely seeing efficiency gains here. You've got your kind of cascade feed forward ratio control methodology, kind of control methodologies in place now, allowing you run closer to your desired targets, reducing fluctuations and variability in your processes, really helpful to kind of make that energy efficiency more tight and more controlled. But then you get to that MPC, so multivariable predictive control. That's really when you're breaking through and making significant differences into your process, able to predict the future present behavior of your operations, optimize your different variables. It allows you to kind of move your control your assets in a way that pushes it to its limit without exceeding thresholds, without overshooting or causing a number of different kind of energy intensive fluctuations in your processes. And that typically has a huge benefit for kind of carbon reductions, emissions reductions, because it allows you to make sure you're, burning less fuel, you're having less flaring going on, all these things that can have significant impacts on decarbonization. And then at the top of it, and that's kind of your new breed of APC. I'm sure John will talk more about it in the coming slides, but this idea of that AI, ML based closed loop control, really looking at kind of adapting your control based on what's happening in the plants today, looking at optimizing resources, minimizing waste, really making decisions that directly cut CO2 emissions. But effectively what we're seeing with APC is that as you move up the hierarchy, as you get more and more invested and more involved in the kind of methodology and the benefits of it, you can kind of reduce more and more waste and improve efficiency in a number of different ways. But yeah, I guess, John, maybe that's a good time to hand over to you to talk a bit more about ABB and where you guys sit in this space today.
Excellent. Thank you. So here's the way I kind of like to think about this when I'm talking with customers, is that this energy optimization is really about three key questions. Okay. And the first one is, where are you? And well, I don't really mean where are you in this digital journey or in the decarbonization journey. I mean, you're operating in an operating space with your processes. Do you know exactly where you are and where you are headed? And model-based technology can help you determine that. So understanding where you are in the operating space is a very important first step, because it allows you to then ask the question, where do you want to be? Where is the money-making operating point for your process? Or if it's not about money-making, it's about decarbonization or emissions or whatever your goal is, where do you want to be to achieve those specific goals? And once you know that a lot of value lies in the answer to that question. But the next logical question is, well, how do I get there? Okay. I don't want to just be slamming valves around to get to some place that in a very inefficient way. I want to do it in a very programmatic way. So when you think about doing optimization or advanced control, these are the three questions that you're going to use models to help you and optimization to help you answer. So I think that's super important. Let's step back just a little bit. And when we say advanced process control, what do we mean? What do we really mean? What are we trying to accomplish? What we're really trying to accomplish is to control the process variability. And I love this plot with the red line, because when an operator is running a plant and the normal everyday things are happening, they're trying to hold a set point, okay? And disturbances are hitting the plant, problems are occurring. And what an APC can do when it's modeling this and implementing control moves every 30 seconds or every minute, it's very persistent. It will suddenly bring that variation down. And when that variation comes down, you are now welcome to move the set points to more optimal places for achieving your production goals. So that we show this in different ways. The red one is very visual. I think that one's good. Reducing the cyan one is showing how you reduce variation. And when you reduce variation, again, you can move to where you want to be. This one in the bottom right corner is also useful because operators are going to be operating within some set of constraints. They want to achieve their goals, their operation goals that they've been given. But they also know that if they run at the edge of the constraints, any little disturbance can push them out. And then they're out of quality or out of constraints, and that's not where they want to be. So they tend to run a little more conservatively. And with an advanced controller on, you can be much more aggressive. It's a little bit like setting your cruise control right at the speed limit where you know you won't get a ticket, right? You feel comfortable that you're not going to accidentally, when you're just daydreaming, accelerate more than you want to accelerate. So APC can push you right to where you want to be, and it'll keep you there. So we know that it's doing that. And one of the ways it's doing that is with these models. We use linear state-space models, and state-space models are particularly good for modeling these processes because they handle the integrators and ramps, they handle disturbances, they have a lot of mathematical characteristics that are useful for the kinds of calculations that we're doing. So we will estimate where we are. And that answers the question I asked before, where are you? So given the plan inputs and the plan outputs, I can estimate where I am and where the process is headed. And given that information, I can then focus on those other two questions, which are the value questions, which is where do I really want to be and how am I going to get there? I implement those control moves, and 30 seconds or a minute later, I'm asking these questions again and solving this problem again. The state space model is very robust to model mismatches. And that's an important thing because processes do change over time. They get fouled or, things change a little bit. So having a fairly robust modeling solution is important. It does manage these disturbances well. We can model some of the disturbances. We know how they're going to come through the system, but some of them are unmeasured. We just have to react to them when we see them. And this modeling technology is good at that. It also manages the integrators really well, which are levels in tanks, levels in different processes that are ever increasing and decreasing, and you need to kind of balance that. So it's good technology for that. We use model identification. We are not doing first principles models here. We are doing empirical modeling. So in order to generate empirical models of your specific process, we're going to step test it. We're going to move the variables in a very prescribed manner in order to get a response in the outputs. And together, this information can be used to identify step response models or state space models that tell me when I move an input, what's going to happen to every output in the process. And then I can use the optimization to control that. So each process is unique and has its own unique quirks. And so by using empirical modeling, we make sure that we have the best possible model for what you're doing. And, Kiran, you asked a little bit and talked a little bit about where AI fits in. One of the things that we've released recently is an automated step testing technology. So in a way, this is using a little bit of artificial intelligence because it's looking at, well, I have a model and I know what's going on with the process and I want to make these steps in order to get some valuable data for my identification. Can I design a step test plan in order to get that data? And so we're helping our users by integrating some of that type of technology. Once you get your data, then you're ready to go into our modeling tool. You're gonna slice out the bad data. You're gonna look at the good data. You're gonna build these step response models. And once you have those models, then you can set up an actual controller. And the controller has a lot of configuration on economics, what constraints are important, how do you want to shape how this controller is running? And so you can rank the things that are important to you. And by giving the optimization those kinds of parameters, it will then drive the process into the way that you want it. And so economics change or constraints may change, and you can adjust that accordingly. So we have a series of little modules. We collect data for you. We have this engineering tool I've talked about. The real-time server is going to be running this 24/7, talking through OPC to your DCS in order to control the plant. And before you implement this, you might use the offline simulator and make sure you got all of the objectives and constraints correct. And we have a control performance manager that does some monitoring of how that controller is running over time so that you have a little bit of feedback. So what's the day in the life of an operator like who's running one of these? I've mentioned a cruise control on a car, and maybe an autopilot on a plane might be a little better analogy because it's a little more complicated than the cruise control on your car. But whether you're using an ABB DCS, in which case we'll build ABB DCS screens that are showing exactly which variables are under control, what are their set points, what are their limits. If you're using a different DCS, we don't mind. Certainly you have what you have, and we can use a web-based interface in order to manage all of that. So the operator is really in charge of turning it on, turning it off, making sure the variables that they want are enabled, and just watching how that is running over time. It's not, I like to use the analogy of the co-pilot of the autopilot of the plane, because we're not really saying that our software is going to help you with takeoff and landing. If there's an emergency, the operator is going to take control of this plant. Some piece of failed equipment, something happens, they're back in control. And so that's kind of the way the advanced control is working. So,
Sean, so can I ask a quick question?
sure.
I suppose APC has been in the market for a long time now. It's not necessarily a new solution as a concept. But at the same time, you still see so many firms having ops tools when it comes to deploying it. Not many of them have used it to its full capabilities. I suppose the question is kind of what's changed over the last few years? Is it just things like AI making it more accessible that's making firms now turn to APC more often? And on top of that, kind of what is the big challenges we're seeing now? What's stopping that continuous adoption?
Yeah. Okay. So that's a good question. You're right. What I have just described, we could have talked about a decade ago, right? It's tried and true technology, and we really are trying to lower the bar of who it can be successful creating and implementing these controllers. And AI is a solution for that. So I talked a little bit about using AI to help you with the step testing. We see other opportunities to use AI to help with the modeling identification, to help with the controller design. And so those are places we're actively researching. We really don't want to wholesale replace this technology with something with an AI technology. And I've seen that in the marketplace, but it gives me concern, because we have a lot of safety and tried and true technology around making sure that we're moving set points correctly around the current set of advanced control products. So what I really want to do is use the AI to help me do those various steps better. Okay, can I take somebody who's not an advanced control engineer, but maybe they're a process engineer? Can I give them the additional tools they need in order to succeed at building these controllers? So not everything is released yet, but those are things that we're thinking about, is how do we accelerate people doing the steps that help them build these controllers. That's an active area of research. There's only so many advanced control engineers in the world, but there's a lot of process engineers, right? So that's our kind of our target audience. We want to help those people succeed. So here's some of the things that we would talk about when we go talk to our customers about what APC helps with. Okay, I talked about reducing variability before. A nice side effect of this is that it stabilizes process operations. That has all sorts of, intangible benefits. Okay, first of all, if your process is consuming resources from elsewhere in the plant, fuel gas, steam, etc., if you are stable, those draws on those other resources are stable, which may stabilize other parts of the plant. It allows operators to concentrate on other parts of the plant that maybe need a little more attention. So it helps them. So some of those intangibles are there, but the tangibles are there as well. We can sit down and on the back of the envelope, we can figure out how much you're going to maximize your throughput by looking at before and after a controller is turned on. We can look at how much you're improving the quality yields and reducing the energy costs. So those are the tangible benefits that everybody wants. I have an example here that this plant is at IRPC, and you can find a success story online at ABB's website. But this was a cogeneration plant. So, they're generating power, and they needed to manage how much energy they're using to generate that power. And so we were able to reduce their steam pressure variability by 50%. They are not using excess steam to generate the power that they need. And that is an immediate benefit that they saw. That allowed them to make sure that they were generating the exact amount of power they want with the exact amount of energy needed. This is just an example of where I said, you stabilize the process and smooth it out, and then everything else seems to run better. So this is a good example of helping them achieve their energy goals. This one I like as well. This is a cogeneration plant for a pulp and paper mill. So again, they're generating energy, but they're generating energy for a purpose on site. And, again, I would point you to this website online. They were able to reduce their natural gas consumption. So immediately 4%. they can see that in the bottom line. They can calculate their return on investment for this project. They get to have the kind of the brag point about the CO2 reduction, because that's, again, something that they might be reporting on a quarterly basis to their shareholders. But in this article, I found it interesting that this plant manager that we're quoting here, he has another quote as well. He says, "Sustainability is integral to our circular business model. We're taking actions to lead the transition to a low-carbon, circular economy by designing out waste, keeping materials in circulation, improving energy efficiency, investing in new technologies, and switching to renewable energy sources." So they have a whole series of goals, and it very, very much resonates with what Kiran was showing before that the customers were saying were their goals. This one, able to get with this immediate return that they're getting, allows them to think more favorably of some of their more expensive projects. They talked about using renewable energy, switching to renewable energy solutions. Well, that's a capital expense that they might have to spend. So this kind of project gets the momentum going on them achieving their goals, and it gives them some cash flow to then, invest in some of the other things. So, I always think that you should get in early with the APC and optimization solutions, because it often is coupled with another type of project. In this case, they coupled it with a DCS upgrade, okay? And the DCS upgrade may not show it's needed for safety, it's needed for security, it's needed for better operations, and it may not show that immediate return that's as easy to show with these optimization and control projects. So coupling them together allows everyone to show the success much quicker. So I kind of like that the way that this worked out. So let's talk about key takeaways and next steps. So we have talked more about the advanced process control solution than the Optimax solution. I'm sorry, Kiran, were you saying something?
Yeah, so I think my computer's lagging a bit, but if you can hear me, I just wanted to ask a quick question. There were some great customer examples. It's good to see the kind of immediate return of investment so your customers are getting. For firms looking to start that journey, have you got any advice on kind of what they should be considering? What does ABB consider as the ideal customer for these type of implementations? Can you talk to maybe some tips for those listening around kind of what they should consider when undertaking these type of projects?
Yeah, I think that there's typically some part of the processes that you're operating that have some kind of pain point. You can't quite keep it on target. You feel like you're just wasting energy. I would look for one of these that are obviously could be optimized, and because what you'll do is you'll find some rapid success with that, and that will set the framework for you to be able to do other projects. So the one thing I would do is look around and see where you have some real issues and opportunities to just operate better. That's a good first step. You can let third parties, whether that would be ABB services or other services people that you like, help you with building out these controllers and these optimizers. And so what you need is someone on site who can kind of be the liaison to make sure that they have everything that they need, get a project going, get the people involved, and get moving. That's where I would often start. There's got to be some low-hanging fruit opportunity that everyone is kind of comfortable with attacking. That's where I would start. So I was saying that we've talked a lot about the advanced process control, which is our empirical modeling for doing point optimization around different processes. When you want to optimize multiple processes and multiple pieces of equipment, we would then get into Optimax, a real-time optimization solution. We haven't talked about that as much, but just know that it kind of layers nicely on top of APC. And so it may be that you have an overall energy monitoring and reporting problem that you want to solve. Maybe the Optimax is the place to start with that. That will highlight where you should be putting advanced control, where you should be putting your efforts. Maybe you just want to start at the bottom and start at APC on a specific process unit. So really, this goes back to my three questions. Where are you? Where do you want to be? And how do you want to get there? Both real-time optimization and advanced control can attack that from different standpoints. So reducing energy costs, improving process stability, achieve that ROI quickly so that you can go on to the next project, and securing lasting performance are all things that are very closely affiliated with the APC projects. So, and then I quote my my buddy from DS Smith here again. Working with ABB has been a massive help in achieving our ambitious sustainability goals. And they do have broad reaching goals, and we're just helping them hack away at them. So with that, I think we're at the end of our slides. Kiran, do you have any final comments that you want to bring forth?
I think I would just say when it comes to tech in general, especially around kind of process control, looking at decarbonization, that the key to all starting decisions is around what is your overall strategic goals here. I mean, that something like an APC, it's working across, as John mentioned, production optimization, energy efficiencies, quality improvements. There's so many different ways to enter that space. So focus that's your key metric. That's your key kind of entry point to the solution. But after that, think of secondary benefits. Think that decarbonization is always going to be there. So do value that kind of secondary point of view and use these technologies to support small low-hanging fruits, small steps in that decarbonization journey. It doesn't have to be a significant investment every single time.
Okay. Well, thank you. And thank you for your time today. I enjoyed the broader perspective that you and your firm bring to this kind of discussions. And I encourage our listeners here today to go and check out our webpage and get some further information about this. Thank you.